So, welcome to Resistance on a Bike, Part 2. I know I've been a little bit repetitive on this, but basically, you have the least resistance on your bike is the pedal bearings and the crank. It's so negligible. Together, it's probably around 1 or 2 watts, and it's going to be standard depending on a little bit depending on your motor speed. But basically, if you maintain 90 RPM, that's not really going to change. Okay, it's going to be the same 1 or 2 watts that it is, and that's it. I mean, look at how easily this spins. I can blow on these pedals with the air out of my voice. I'm not going to do it because I can't videotape that, but and this will move. If there was no chain on the chain ring, you can blow with air on your pedal out of your lungs, and it should be enough to move your pedals. If it's not, there's something wrong with your bearings in your bottom bracket. So that's altogether probably 3 or 4 watts at the very, very most at really high RPM. Okay. Then there's your chain, which is very similar to that, except it's a little bit more watts. Okay, because the chain has to make contact, and because the chain of the bicycle is going to be tensioned. Alright, and that tension is what's providing a little tiny bit of friction. And that number doesn't change. It changes with RPM, but basically, if your RPM remains close to the same, it's going to be the same number. But then there's drivetrain friction. Okay, with a chain drive system like this, it's around 1 to 2%. With an internal hub gear, and I'm not kidding, you can look this up, this is a problem that cars have. Alright? It's around 5 to 10%. Okay? And the infinite variable drives are worse than that. You're talking 10 to 15%. Okay? The bigger the gear with infinite variable gears, the bigger the gear is, the more efficient it is. Okay? When you max out the gear, I think that's how it basically works. Okay? But with a normal internal hub gear system, you're talking at least 3 or 4%. But you're really talking, and you can look up the diagrams on how these work. There's just so much compression friction because there's a lot of compression between the gears to keep them together while they're rotating in and out. Alright, so for them to, rotate with each other, because you have 45-degree, clearance between gears, well, not clearance, the angles between the gears is like 45 degrees. So you're looking at some serious friction there. That's what's slowing that drivetrain system down. I'm actually going to get internal hubs on this bike, because my steel derailleur hanger has been damaged so much that it's not aligned anymore, and it's impossible to align at this point. Okay, and I've only crashed on this bike 3 times, so I don't know why 3 shops. Colorado Springs has the worst bike shops ever, because 3 shops tried this and they still can't straighten out. Back to the point though, we talked about tire resistance, which is linear with your speed, and that matters, because if you're drafting something, you still can't just go 70 miles an hour. You have to overcome the watts it takes for every 10 miles per hour. So let's pretend, for example, that somebody weighs enough that and has narrow enough tires with little enough rolling resistance. Okay, that it's all the right amount. Let's just say that every 10 miles per hour is 40 watts. Okay, we'll multiply that out. All right, so 100 miles per hour is 400 watts. Plus, then you have also the drivetrain. Okay, so you're at least doing 400 watts to overcome that, right? Okay, and that's not including acceleration with momentum and stuff. That's just being pulled up to that speed physically by like a cable attached to your bike, and then being let go and staying that speed. So we're not even talking about inertia, which we'll get to. Okay, but with the rolling resistance in the tires, it's less in the bearings, but you still have bearing resistance. And then the drivetrain at 400 watts, let's say the drivetrain is 1% efficient, 99% efficient. And so you have 1% of 400 watts is 4 watts. So you're talking 404 watts. It's very efficient, but it's there. That extra 4 watts is there. Okay, it matters more when you're doing over 1,000 watts, but it still matters at 400. Okay, so 404 watts. All right, then a little bit of watts in the for the bearings and for other stuff. And you're talking about 420 watts. You're also talking about acceleration. And we'll get to acceleration, but acceleration obviously means that you have to have more watts for whatever speed you're going to get up to that speed, to get up to gain speed. And whatever maximum speed you want, you have to do more watts than that in order to reach that speed eventually. So if I want to reach 100 miles an hour, it's going to take me, let's just say that when I'm going that fast, it's going to be 450 watts. I have to do 460 watts to get there, and you can divide out the time to how long it would take to get to that speed with only 10 watts of a deficit. So that's a bit of a problem because that would take you a very long time. Okay, you get up to like 80 miles an hour pretty quickly, but the difference between 80 and 100 is so your power is so small compared to how much faster you still have to accelerate, that it's going to take you a couple minutes once you get up to 80 miles an hour to get faster than that. And that's if aerodynamics has been completely removed, which never happens. Okay, you cannot remove aerodynamics completely. And the sense that trucks actually pull you on the highway is incorrect. Their air pressure will not actually, well, maybe, I don't know enough about it to say that it won't actually pull you. But I can say that when there's a bike in front of you, it's not going to actually pull you. A truck, maybe, because they're so unaerodynamic. So let me talk about aerodynamics. Aerodynamics is a function of is a cubic function of the square. Okay, you can look up what that means because even I don't really get what that point is. Okay, so 10 miles per hour, and remember, rolling resistance matters. So 10 miles per hour may be 20, 30 watts for how heavy you weigh. And the heavier you weigh, the more that matters. And we'll talk about hills and inertia in some other pair of videos. But you have to overcome that stuff. Okay, inertia really is the greatest force you have to overcome. Okay, I want to just say that now. So, inertia really is the greatest force you got to overcome, but air resistance matters. So, let's just say that you can go 20 miles an hour, and you want to be able to go 30 miles an hour, and you used to go 10 miles an hour, and it hasn't been that hard for you to overcome the speed differences. It requires changing your gear up, changing your equipment, and going from 10 to 20 miles per hour as your average speed and whatnot. You've been able to do that pretty easily. It took you a couple months of training to do that. Well, I'm sorry, but because of wind resistance and air resistance, okay, it's really air. Wind is not air resistance. Wind is what wind is. Okay, air resistance is resistance. So if you want to go faster in the air, what you have to do is a lot more than 2 more months of training to go, even though it's the same speed difference, and it's actually percentage-wise, it's only 50% of your speed faster, whereas going from 10 to 20 miles per hour was 100% of your speed faster. Okay, so you would say you doubled your watts, but that's not necessarily going to work, because you don't just double your watts, you actually triple or even quadruple them to go from 20 to 30. And to go from 30 to 40, you quintuple what it took to go 30 miles an hour. You have to understand how crazy that is. To go from 40 to 50 in the same position with the same gear, you have to then sextuple the power it takes for you to go 40 miles an hour. Or so. I'm pulling numbers out of out of my posterior. I don't really know what the numbers are for that. So to go faster, you have to overcome wind resistance. And on a bike like I'm showing you right here, that is difficult. On this cruiser over here, this beach cruiser, it's much easier to overcome air resistance. Okay, that's a joke. So, realistically speaking, overcoming wind resistance is easier when you work on flexibility training to get yourself lower to the ground and more aerodynamic. But that's not really going to make everything happy, because your watts are going to decrease when you do that. So on flat land, your weight doesn't matter all that much. It does in acceleration, which I'll talk about in another video, but it does not matter all that much when overcoming wind resistance, air resistance. What matters is your ratios from being aerodynamic to your power. Okay, so your aerodynamics ratio to power is what matters. You want more power, yes, and you also want more aerodynamics. To get that, you need to work on flexibility. Okay, bike fit matters. I've noticed that doing my own little adjustments over time works a lot better than going to a bike shop. But if you're new and you don't have 10,000 hours of bicycling experience like I do, you might want to go to a bike shop and go ahead and do that. I mean, that's gonna be the best way, the fastest way for you to get more results from your bike fit. But that bike fit isn't going to make you faster if you reduce your comfort. So you have to be comfortable and more upright to gain more watts, and you have to be uncomfortable and more down to gain more aerodynamics. So downhill without pedaling at all, this is always the best. But going on flat land or even uphill, you want to adjust for more and more power. Okay, also in sprints, you want to be more aerodynamic. But when you are, especially when you are just riding in a pack, you want to care less about that and more about pedaling efficiency and power and speed. So you might even be up here instead of even here. Okay, compared to this bike, you might want to be up like this, maybe even up to here at that angle. This is for when you're more alone, when you're trying to break away from the pack. You don't want your own aerodynamics to go. So, I don't know. I'm going to do one more video on aerodynamics. But that is the other force that's slowing you down. So you have those basically, it's basically 7 forces that you have to overcome to go faster. Okay, you have your chain resistance, and I guess you could group your chain resistance, your pedal resistance, pedal bearings, bottom bracket bearings, and chain into one thing, because that doesn't change. It's a solid number. It doesn't change according to your RPM. You have your drivetrain resistance, which with a chain drive system, it does get worse when you do what's called cross chaining, which is where you're at a lower gear ratio in the back and a higher gear ratio in the front, or a lower gear ratio in the front and a higher gear ratio in the back, which there's no reason to do that, okay, other than there is reasons to do that, and I'll cover that some other time, but there's no real reason to do that. But that does make it even less efficient. So there's those 2 different forces, then your pedals, then your tires, your bearings, and your aerodynamics and your inertia. So aerodynamics, inertia, tires, bearings, drivetrain, and then chain. Okay? That is it.